This is for problem 81. So 81 says, find the angle between the forces given the magnitude and their resultant. Write force 1 as a vector in the direction of the positive x-axis and force 2 as the vector of an angle with the positive x-axis. So, first things first, I just listed out what my numbers are. So let's talk about what that means. If I were to draw this on the coordinate axis, let's just draw a quick graph. Force 1, 45, would just be represented going in this direction. So it really just has a direction of 45i, since it's just one direction. So let's just call this one U. Force 2, 60. So that means that it's going 60 in this direction, but we don't necessarily know what the components are for x and y. So the general form, we could write that for this one, we'll call this V. It's going to be 60 cosine theta I plus 60 sine theta j. So that'll cover my basis for vector 2. So the last thing is we know that the resultant, which would be like the direction of both of their forces combined. So really what happens, and I'll try to draw this out in black, is imagine if you were to put these two together and they would go off in this direction. That's the resultant force. So it's basically what I have in black. So when we combine these two, we have a resultant force of 90. So one thing we know we can do is we could actually find the magnitude of these things. So let's just kind of write a general formula. So U plus V, the magnitude, is equal to 90 because that's the resultant force. So really, this right here is equal to the magnitude of that. So let's find the magnitude of U plus V. So U plus V would just be taking 45i, and I can just leave it as 45, plus 60 cosine theta, because that's the I part, so I'm just combining my two I parts, and then plus 60 sine theta for the j. So then what would end up happening is I can square these two, and then I have to combine these two and square them, and then take the square root. So this is all what the magnitude of U of plus V is. And then all of this is going to be equal to 90 squared. Because now what I'm doing is actually finding out what the actual magnitude is. So I'm going to simplify all of this by expanding it out. So when I multiply all the way through, numbers 45 squared is 2025. Multiply these two together and then by 2, so I get 540 cosine theta, and then the last part here I'm going to get 360 cosine theta. So that's all of this is right here, and then plus 360 sine theta, and then this is all equal to 90 squared theta. I'm going to wait to square it since I'm out of space. Now if you notice one thing here, we have a cosine and a sine, and they both have a 360. I could drop the parenthesis, leave it as a plus, and then what I'm going to end up doing is factoring out a 360 from this part. Now this is still under the square root. Well, actually when I squared the 90, it takes out the square root, so I actually rewrite this. Sorry, the magnitude of both sides squared would be equal to 90 squared. So let's go through the process of combining like terms. So nothing I can combine over here, so 2025 plus 540 cosine theta plus 360 cosine theta plus sine theta, and that's going to be equal to 8100. Cosine and sine make 1, so that goes away. Now I can do 360 plus 2025, and then really what I want to do is figure out what the angle is. So from here, let's go ahead and figure out what the angle will be. So I'm just going to subtract everything over, so I should end up with 540 cosine theta equals to 2475. And then I can divide and then do the cosine inverse. And when I solve for that, should get the cosine inverse to be 62.7. Cool. And that's ultimately what they want us to find. So that's our answer for 81. This is more of what you would see in physics, in more advanced physics, and like using vectors. But this is kind of the application of where this stuff would be used. So if you're planning to take physics, definitely a helpful question to answer. All right, that's 81.